Boeing 767.
The Boeing 767 is a mid to large size, long-range, wide-body twin-engine jet airliner built by Boeing Commercial Airplanes. It was the manufacturer's first wide-body twin-jet and its first airliner with a two-crew glass cockpit. The aircraft has two turbofan engines, a conventional tail, and, for reduced aerodynamic drag, a supercritical wing design. Designed as a smaller wide-body airliner than earlier aircraft such as the 747, the 767 has seating capacity for 181 to 375 persons and a design range of 3,850 to 6,385 nautical miles, depending on variant. Development of the 767 occurred in tandem with a narrow-body twin-jet, the 757, resulting in shared design features which allow pilots to obtain a common type rating to operate both aircraft. The 767 is produced in three fuselage lengths. The original 767-200 entered service in 1982, followed by the 767-300 in 1986 and the 767-400ER, an extended range (ER) variant, in 2000. The extended range 767-200ER and 767-300ER models entered service in 1984 and 1988, respectively, while a production freighter version, the 767-300F, debuted in 1995. Conversion programs have modified passenger 767-200 and 767-300 series aircraft for cargo use, while military derivatives include the E-767 surveillance aircraft, the KC-767 and KC-46 aerial tankers, and VIP transports. Engines featured on the 767 include the General Electric CF6, Pratt & Whitney JT9D and Pilot 4000, and Rolls-Royce RB211 turbofans. United Airlines first placed the 767 in commercial service in 1982. The aircraft was initially flown on domestic and transcontinental routes, during which it demonstrated the reliability of its twin-jet design. In 1985, the 767 became the first twin-engined airliner to receive regulatory approval for extended overseas flights. The aircraft was then used to expand non-stop service on medium to long-haul intercontinental routes. In 1986, Boeing initiated studies for a higher-capacity 767, ultimately leading to the development of the 777, a larger wide-body twin-jet. In the 1990s, the 767 became the most frequently used airliner for transatlantic flights between North America and Europe. The 767 is the first twin-jet wide-body type to reach 1,000 aircraft delivered. As of December 2013, Boeing has received 1,110 orders for the 767 from 71 customers. 1,061 have been delivered. A total of 838 of these aircraft were in service in July 2012. The most popular variant is the 767-300ER, with 582 delivered. Delta Airlines is the largest operator, with 94 aircraft. Competitors have included the Airbus A300, A310, and A330-200, while a successor, the 787 Dreamliner, entered service in October 2011.
Development. Background.
In 1970, Boeing's 747 became the first wide-body jetliner to enter service. The 747 was the first passenger jet that was wide enough to feature a twin-hull cabin. 2 years later, the manufacturer began a development study, codenamed 7X7, for a new wide-body aircraft intended to replace the 707 and other early-generation narrow-body jets. The aircraft would also provide twin-hull seating, but in a smaller fuselage than the existing 747, McDonnell Douglas DC-10, and Lockheed L-1011 TRI wide-bodies. To defray the high cost of development, Boeing signed risk-sharing agreements with Italian corporation Aeroitalia and the Civil Transport Development Corporation, CTDC, a consortium of Japanese aerospace companies. This marked the manufacturer's first major international joint venture, and both Aeritalia and the CTDC received supply contracts in return for their early participation. The initial 7X7 was conceived as a short takeoff and landing airliner intended for short-distance flights, but customers were unenthusiastic about the concept, leading to its redefinition as a mid-size, transcontinental range airliner. At this stage the proposed aircraft featured 2 or 3 engines, with possible configurations including over-wing engines and a T-tail. By 1976, a twinjet layout, similar to the one which had debuted on the Airbus A300, became the baseline configuration. The decision to use 2 engines reflected increased industry confidence in the reliability and economics of new-generation jet powerplants. While airline requirements for new wide-body aircraft remained ambiguous, the 7X7 was generally focused on mid-size, high-density markets. As such, it was intended to transport large numbers of passengers between major cities. Advancements in civil aerospace technology, including high bypass ratio turbofan engines, new flight deck systems, aerodynamic improvements, and lighter construction materials were to be applied to the 7X7. Many of these features were also included in a parallel development effort for a new mid-size narrow-body airliner, codenamed 7N7, which would become the 757. Work on both proposals proceeded through the airline industry upturn in the late 1970s. In January 1978, Boeing announced a major extension of its Everett factory, which was then dedicated to the manufacture of the 747, to accommodate its new wide-body family. In February 1978, the new jetliner received the 767 model designation, and 3 variants were planned, a 767-100 with 190 seats, a 767-200 with 210 seats, and a Trijet 767 Mr. LR version with 200 seats intended for intercontinental routes. The 767 Mr. LR was subsequently renamed 777 for differentiation purposes. The 767 was officially launched on July 14, 1978, when United Airlines ordered 30 of the 767-200 variant, followed by 50 more 767-200 orders from American Airlines and Delta Airlines later that year. The 767-100 was ultimately not offered for sale, as its capacity was too close to the 757 seating, while the 777 Trijet was eventually dropped in favor of standardizing around the twinjet configuration.
Design effort.
In the late 1970s, operating cost replaced capacity as the primary factor in airliner purchases. As a result, the 767's design process emphasized fuel efficiency from the outset. Boeing targeted a 20 to 30% cost saving over earlier aircraft, mainly through new engine and wing technology. As development progressed, engineers used computer-aided design for over one-third of the 767's design drawings, and performed 26,000 hours of wind tunnel tests. Design work occurred concurrently with the 757 twinjet, leading Boeing to treat both as almost one program to reduce risk and cost. Both aircraft would ultimately receive shared design features, including avionics, flight management systems, instruments, and handling characteristics. Combined development costs were estimated at $3.5 to $4 billion. Early 767 customers were given the choice of Pratt & Whitney JT9D or General Electric CF6 turbofans, marking the first time that Boeing had offered more than one engine option at the launch of a new airliner. Both jet engine models had a maximum output of 48,000 pounds force, 210 kilonewtons, of thrust. The engines were mounted approximately one-third the length of the wing from the fuselage, similar to previous wide-body trajets. The larger wings were designed using an aft-loaded shape which reduced aerodynamic drag and distributed lift more evenly across their surface span than any of the manufacturer's previous aircraft. The wings provided higher altitude cruise performance, added fuel capacity, and expansion room for future stretched variants. The initial 767-200 was designed for sufficient range to fly across North America or across the northern Atlantic, and would be capable of operating routes up to 3,850 nautical miles, 7,130 kilometers. The 767's fuselage width was set midway between that of the 707 and the 747 at 16.5 feet, 5.03 m. While it was narrower than previous wide-body designs, 7 abreast seating with 2 aisles could be fitted, and the reduced width produced less aerodynamic drag. However, the fuselage was not wide enough to accommodate 2 standard LD-3 wide-body unit load devices side by side. As a result, a smaller container, the LD-2, was created specifically for the 767. The adoption of a conventional tail design also allowed the rear fuselage to be tapered over a shorter section, providing for parallel aisles along the full length of the passenger cabin, and eliminating irregular seat rows toward the rear of the aircraft. The 767 was the first Boeing wide-body to be designed with a 2-crew digital glass cockpit. Cathode ray tube, CRT, color displays and new electronics replaced the role of the flight engineer by enabling the pilot and co-pilot to monitor aircraft systems directly. Despite the promise of reduced crew costs, United Airlines initially demanded a conventional 3-person cockpit, citing concerns about the risks associated with introducing a new aircraft. The carrier maintained this position until July 1981. When a U.S. presidential task force determined that a crew of 2 was safe for operating wide-body jets. A 3-crew cockpit remained as an option and was fitted to the first production models. Ansett Australia ordered 767s with 3-crew cockpits due to union demands. It was the only airline to operate 767s so configured. The 767's 2-crew cockpit was also applied to the 757, allowing pilots to operate both aircraft after a short conversion course, and adding incentive for airlines to purchase both types.
Production and testing.
To produce the 767, Boeing formed a network of subcontractors which included domestic suppliers and international contributions from Italy's Air Italia and Japan's CTDC. The wings and cabin floor were produced in-house, while Air Italia provided control surfaces. Boeing Vertol made the leading edge for the wings, and Boeing Wichita produced the forward fuselage. The CTDC provided multiple assemblies through its constituent companies, namely Fuji Heavy Industries, wing fairings and gear doors, Kawasaki Heavy Industries, center fuselage, and Mitsubishi Heavy Industries, rear fuselage, doors, and tail. Components were integrated during final assembly at the Everett factory. For expedited production of wing spars, the main structural member of aircraft wings, the Everett factory received robotic machinery to automate the process of drilling holes and inserting fasteners. This method of wing construction expanded on techniques developed for the 747. Final assembly of the first aircraft began on July 6, 1979. The prototype aircraft, registered N767BA and equipped with JT9D turbofans, rolled out on August 4, 1981. By this time, the 767 program had accumulated 173 firm orders from 17 customers, including Air Canada, All Nippon Airways, Britannia Airways, Trans-Brazil, and Trans World Airlines, TWA. On September 26, 1981, the prototype took its maiden flight under the command of company test pilots Tommy Edmonds, Lou Wallach, and John Britt. The maiden flight was largely uneventful, save for the inability to retract the landing gear owing to a hydraulic fluid leak. The prototype was used for subsequent flight tests. The 10-month 767 flight test program utilized the first 6 aircraft built. The first 4 aircraft were equipped with JT9D engines, while the 5th and 6th were fitted with CF6 engines. The test fleet was largely used to evaluate avionics, flight systems, handling, and performance, while the 6th aircraft was used for route-proving flights. During testing, pilots described the 767 as generally easy to fly, with its maneuverability unencumbered by the bulkiness associated with larger wide-body jets. Following the successful completion of 1,600 hours of flight tests, the JT9D-powered 767-200 received certification from the U.S. Federal Aviation Administration, FAA, and the UK Civil Aviation Authority, CAA, in July 1982. The first delivery occurred on August 19, 1982, to United Airlines. The CF6-powered 767-200 received certification in September 1982, followed by the first delivery to Delta Airlines on October 25, 1982.
Service entry and operations.
The 767 entered service with United Airlines on September 8, 1982. The aircraft's first commercial flight used a JT9D-powered 767-200 on the Chicago to Denver route. The CF6-powered 767-200 commenced service 3 months later with Delta Airlines. Upon delivery, early 767s were mainly deployed on domestic routes, including U.S. transcontinental services. American Airlines and TWA began flying the 767-200 in late 1982, while Air Canada, China Airlines, and El Al began operating the aircraft in 1983. The aircraft's introduction was relatively smooth, with few operational glitches and greater dispatch reliability than prior jetliners. In its first year, the 767 logged a 96.1% rate of takeoff without delay due to technical issues, which exceeded the industry average for new aircraft. Operators reported generally favorable ratings for the twinjet sound levels, interior comfort, and economic performance. Resolved issues were minor and included the recalibration of a leading-edge sensor to prevent false readings, the replacement of an evacuation slide latch, and the repair of a tailplane pivot to match production specifications. Seeking to capitalize on its new wide-body's potential for growth, Boeing offered an extended-range model, the 767-200ER, in its first year of service. Ethiopian Airlines placed the first order for the type in December 1982. Featuring increased gross weight specifications and greater fuel capacity, the extended-range model could carry heavier payloads at distances up to 6,385 nautical miles, 11,825 kilometers, and was targeted at overseas customers. The 767-200ER entered service with El Al on March 27, 1984. The type was mainly ordered by international airlines operating medium-traffic, long-distance flights. In the mid-1980s, the 767 spearheaded the growth of twinjet flights across the northern Atlantic under extended-range twin-engine operational performance standards, ETOPS, regulations, the FAA's safety rules governing transoceanic flights by aircraft with two engines. Before the 767, over-water flight paths of twinjets could be no more than 90 minutes away from diversion airports. In May 1985, the FAA granted its first approval for 120-minute ETOPS flights to 767 operators, on an individual airline basis starting with TWA, provided that the operator met flight safety criteria. This allowed the aircraft to fly overseas routes at up to 2 hours distance from land. The larger safety margins were permitted because of the improved reliability demonstrated by the twinjet and its turbofan engines. The FAA lengthened the ETOPS time to 180 minutes for CF6-powered 767s in 1989, making the type the first to be certified under the longer duration, and all available engines received approval by 1993. Regulatory approval spurred the expansion of transoceanic 767 flights and boosted the aircraft's sales.
Stretched derivatives.
Forecasting airline interest in larger capacity models, Boeing announced the stretched 767-300 in 1983 and the extended-range 767-300ER in 1984. Both models offered a 20% passenger capacity increase, while the extended-range version was capable of operating flights up to 5,990 nautical miles, 11,090 kilometers. Japan Airlines placed the first order for the 767-300 in September 1983. Following its first flight on January 30, 1986, the type entered service with Japan Airlines on October 20, 1986. The 767-300ER completed its first flight on December 9, 1986, but it was not until March 1987 that the first firm order, from American Airlines, was placed. The type entered service with American Airlines on March 3, 1988. The 767-300 and 767-300ER gained popularity after entering service, and came to account for approximately two-thirds of all 767s sold. After the debut of the first stretched 767s, Boeing sought to address airline requests for even more capacity by proposing larger models, including a partial double-deck version informally named the Hunchback of Mukilteo, from a town near Boeing's Everett factory, with a 757 body section mounted over the aft main fuselage. In 1986, the manufacturer announced the 767X, a revised model with extended wings and a wider cabin, but received little interest. By 1988, the 767X had evolved into an all-new twinjet, which revived the 777 designation. Until the 777's 1995 debut, the 767-300 and 767-300ER remained Boeing's second-largest wide bodies behind the 747. Buoyed by a recovering global economy and ETOPS approval, 767 sales accelerated in the mid to late 1980s, with 1989 being the most prolific year with 132 firm orders. By the early 1990s, the wide-body twinjet had become its manufacturer's annual best-selling aircraft, despite a slight decrease due to economic recession. During this period, the 767 became the most common airliner for transatlantic flights between North America and Europe. By the end of the decade, 767s crossed the Atlantic more frequently than all other aircraft types combined. The 767 also propelled the growth of point-to-point flights which bypassed major airline hubs in favor of direct routes. Taking advantage of the aircraft's lower operating costs and smaller capacity, operators added non-stop flights to secondary population centers, thereby eliminating the need for connecting flights. The increase in the number of cities receiving non-stop services caused a paradigm shift in the airline industry as point-to-point travel gained prominence at the expense of the traditional hub-and-spoke model. In February 1990, the first 767 equipped with Rolls-Royce RB211 turbofans, a 767-300, was delivered to British Airways. 6 months later, the carrier temporarily grounded its entire 767 fleet after discovering cracks in the engine pylons of several aircraft. The cracks were related to the extra weight of the RB211 engines, which are 2,205 pounds, 1,000 kilograms, heavier than other 767 engines. During the grounding, interim repairs were conducted to alleviate stress on engine pylon components, and a parts redesign in 1991 prevented further cracks. Boeing also performed a structural reassessment, resulting in production changes and modifications to the engine pylons of all 767s in service. In January 1993, following an order from UPS Airlines, Boeing launched a freighter variant, the 767-300F, which entered service with UPS on October 16, 1995. The 767-300F featured a main deck cargo hold, upgraded landing gear, and strengthened wing structure. In November 1993, the Japanese government launched the first 767 military derivative when it placed orders for the E-767, an airborne early warning and control (AWACS) variant based on the 767-200ER. The first two E-767s, featuring extensive modifications to accommodate surveillance radar and other monitoring equipment, were delivered in 1998 to the Japan Self-Defense Forces. In November 1995, after abandoning development of a smaller version of the 777, Boeing announced that it was revisiting studies for a larger 767. The proposed 767-400X, a second stretch of the aircraft, offered an over 12% capacity increase versus the 767-300, and featured an upgraded flight deck, enhanced interior, and wider wingspan. The variant was specifically aimed at Delta Airlines pending replacement of its aging Lockheed L-1011 TRI stars, and faced competition from the A330-200, a shortened derivative of the Airbus A330. In March 1997, Delta Airlines launched the 767-400ER when it ordered the type to replace its L-1011 fleet. In October 1997, Continental Airlines also ordered the 767-400ER to replace its McDonnell Douglas DC-10 fleet. The type completed its first flight on October 9, 1999, and entered service with Continental Airlines on September 14, 2000.
Further developments.
In the early 2000s, cumulative 767 deliveries approached 900. But new sales declined during an airline industry downturn. In 2001, Boeing dropped plans for a longer-range model, the 767-400ERX, in favor of the proposed Sonic Cruiser, a new jetliner which aimed to fly 15% faster while having comparable fuel costs as the 767. The following year, the manufacturer announced the KC-767 tanker transport, a second military derivative of the 767-200ER. Launched with an order in October 2002 from the Italian Air Force, the KC-767 was intended for the dual role of refueling other aircraft and carrying cargo. The Japanese government became the second customer for the type in March 2003. In May 2003, the United States Air Force, USAF, announced its intent to lease KC-767s to replace its aging KC-135 tankers. The plan was suspended in March 2004 amid a conflict of interest scandal, resulting in multiple U.S. government investigations and the departure of several Boeing officials, including Philip Condit, the company's chief executive officer, and chief financial officer Michael Sears. The first KC-767s were delivered in 2008 to the Japan Self-Defense Forces. In late 2002, after airlines expressed reservations about its emphasis on speed over cost reduction, Boeing halted development of the Sonic Cruiser. The following year, the manufacturer announced the 7E7, a mid-size 767 successor made from composite materials which promised to be 20% more fuel efficient. The new jetliner was the first stage of a replacement aircraft initiative called the Boeing Yellowstone Project. Customers embraced the 7E7, later renamed 787 Dreamliner, and within 2 years it had become the fastest-selling airliner in the company's history. In 2005, Boeing opted to continue 767 production despite record Dreamliner sales, citing a need to provide customers waiting for the 787 with a more readily available option. Subsequently, the 767-300ER was offered to customers affected by 787 delays, including All Nippon Airways and Japan Airlines. Some aging 767s, exceeding 20 years in age, were also kept in service past planned retirement dates due to the delays. To extend the operational lives of older aircraft, airlines increased heavy maintenance procedures, including D-check teardowns and inspections for corrosion, a recurring issue on aging 767s. The first 787s would ultimately enter service with All Nippon Airways in October 2011, 3.5 years behind schedule. In 2007, the 767 received a production boost when UPS and DHL Aviation placed a combined 33 orders for the 767-300F. Renewed freighter interest led Boeing to consider enhanced versions of the 767-200 and 767-300F with increased gross weights, 767-400ER wing extensions, and 777 avionics. However, net orders for the 767 declined from 24 in 2008 to just 3 in 2010. During the same period, operators upgraded aircraft already in service. In 2008, the first 767-300ER retrofitted with blended winglets from Aviation Partners Incorporated debuted with American Airlines. The manufacturer sanctioned winglets, at 11 feet, 3.35 m, in height, improved fuel efficiency by an estimated 6.5%. Other carriers including All Nippon Airways and Delta Airlines also ordered winglet kits. On February 2, 2011, the 1767 rolled out, destined for All Nippon Airways. The aircraft was the 91st 767-300ER ordered by the Japanese carrier, and with its completion the 767 became the second wide-body airliner to reach the 1,000-unit milestone after the 747. The 1,000th aircraft also marked the last model produced on the original 767 assembly line. Beginning with the 1,001st aircraft, production moved to another area in the Everett factory which occupied nearly half the space as before. The new assembly line made room for 787 production and aimed to boost manufacturing efficiency by over 20%. At the inauguration of its new assembly line, the 767's order backlog numbered approximately 50, only enough for production to last until 2013. Despite the reduced backlog, Boeing officials expressed optimism that additional orders were forthcoming. On February 24, 2011, the USAF announced its selection of the KC-767 Advanced Tanker, an upgraded variant of the KC-767, for its KCX Fleet Renewal Program. The selection followed 2 rounds of tanker competition between Boeing and Airbus parent EADS, and came 8 years after the USAF's original 2003 announcement of his plan to lease KC-767s. The tanker order encompassed 179 aircraft and was expected to sustain 767 production past 2013. In December 2011, FedEx Express announced a 767-300F order for 27 aircraft to replace its DC-10 freighters, citing the USAF tanker order and Boeing's decision to continue production as contributing factors. FedEx Express announced an agreement to buy an additional 19 of the 300F variant in June 2012. 15 of these have been added to Boeing's orders and deliveries table as of June 30, 2012.
Design. Overview.
The 767 is a low-wing cantilever monoplane with a conventional tail unit featuring a single fin and rudder. The wings are swept at 31.5 degrees and optimized for a cruising speed of Mach 0.8, 533 miles per hour or 858 kilometers per hour. Each wing features a supercritical cross-section and is equipped with 6-panel leading-edge slats, single and double-slotted flaps, inboard and outboard ailerons, and 6 spoilers. The airframe further incorporates carbon fiber reinforced plastic composite wing surfaces, Kevlar fairings and access panels, plus improved aluminum alloys, which together reduce overall weight by 1,900 pounds, 860 kilograms, versus preceding aircraft. To distribute the aircraft's weight on the ground, the 767 has a retractable tricycle landing gear with 4 wheels on each main gear and 2 for the nose gear. The original wing and gear design accommodated the stretched 767-300 without major changes. The 767-400ER features a larger, more widely spaced main gear with 777 wheels, tires, and brakes. To prevent damage if the tail section contacts the runway surface during takeoff, 767-300 and 767-400ER models are fitted with a retractable tail skid. The 767 has exit doors near the front and rear of the aircraft on the left side. In addition to shared avionics and computer technology, the 767 uses the same auxiliary power unit, electric power systems, and hydraulic parts as the 757. A raised cockpit floor and the same forward cockpit windows result in similar pilot viewing angles. Related design and functionality allows 767 pilots to obtain a common type rating to operate the 757 and share the same seniority roster with pilots of either aircraft.
Flight systems.
The original 767 flight deck uses 6 Rockwell Collins quart screens to display Electronic Flight Instrument System, EFIS, and Engine Indication and Crew Alerting System, EICAS, information, allowing pilots to handle monitoring tasks previously performed by the flight engineer. The CRTs replace conventional electromechanical instruments found on earlier aircraft. An enhanced flight management system, improved over versions used on early 747s, automates navigation and other functions, while an automatic landing system facilitates CATIOB instrument landings in low-visibility situations. The 767 became the first aircraft to receive CATIOB certification from the FAA for landings with 980 feet, 300 m, minimum visibility in 1984. On the 767-400ER, the cockpit layout is simplified further with 6 Rockwell Collins liquid crystal display, LCD, screens, and adapted for similarities with the 777 and the next generation 737. To retain operational commonality, the LCD screens can be programmed to display information in the same manner as earlier 767s. In 2012, Boeing and Rockwell Collins launched a further 787-based cockpit upgrade for the 767, featuring 3 landscape format LCD screens that can display 2 windows each. The 767 is equipped with 3 redundant hydraulic systems for operation of control surfaces, landing gear, and other equipment. Each engine powers a separate hydraulic system, and the third system uses electric pumps. A ram air turbine is fitted to provide power for basic controls in the event of an emergency. An early form of fly-by-wire is employed for spoiler operation, utilizing electric signaling instead of traditional control cables. The fly-by-wire system reduces weight and provides for the independent operation of individual spoilers.
Interior.
The 767 features a twin-hull cabin with a typical configuration of 6 abreast in business class and 7 across in economy. The standard 7 abreast, 2-3-2 economy class layout places approximately 87% of all seats at a window or aisle. As a result, the aircraft can be largely occupied before center seats need to be filled, and each passenger is no more than 1 seat from the aisle. It is possible to configure the aircraft with extra seats for up to an 8 abreast configuration, but this results in a cramped cabin and is therefore uncommon. The 767 interior introduced larger overhead bins and more lavatories per passenger than previous aircraft. The bins are wider to accommodate garment bags without folding, and strengthened for heavier carry-on items. A single, large galley is installed near the aft doors, allowing for more efficient meal service and simpler resupply while at airports. Passenger and service doors are an overhead plug type, which retract upwards, and commonly used doors can be equipped with an electric assist system. In 2000, a 777-style interior, known as the Boeing Signature Interior, debuted on the 767-400ER. Subsequently adopted for all new-build 767s, the Signature Interior features even larger overhead bins, indirect lighting, and sculpted, curved panels. The 767-400ER also received larger windows derived from the 777. Older 767s can be retrofitted with the Signature Interior. Some operators have adopted a simpler modification known as the Enhanced Interior, featuring curved ceiling panels and indirect lighting with minimal modification of cabin architecture, as well as aftermarket modifications such as the new-look 767 package by Heath Techner.
Variants.
The 767 has been produced in 3 fuselage lengths. These debuted in progressively larger form as the 767-200, 767-300, and 767-400ER, respectively. Longer-range variants include the 767-200ER and 767-300ER, while cargo models include the 767-300F, a production freighter, and conversions of passenger 767-200 and 767-300 models. When referring to different variants, Boeing and airlines often collapse the model number, 767, and the variant designator, for example -200 or -300, into a truncated form, for example 762, or 763. Subsequent to the capacity number, designations may or may not append the range identifier. The International Civil Aviation Organization, ICAO, aircraft type designator system uses a similar numbering scheme, but adds a preceding manufacturer letter. All variants based on the 767-200 and 767-300 are classified under the codes B762 and B763, respectively, while the 767-400ER receives the designation of B764.
767-200.
The 767-200 was the original model and entered service with United Airlines in 1982. The type has been used primarily by mainline U.S. carriers for domestic routes between major hub centers such as Los Angeles to Washington. The 767-200 was the first aircraft to be used on transatlantic ETOPS flights, beginning with TWA on February 1, 1985 under 90-minute diversion rules. Deliveries for the variant totaled 128 aircraft. There were 55 passenger and freighter conversions of the model in commercial service as of July 2013. The type's competitors included the Airbus A300 and A310. The 767-200 ceased production in the late 1980s due to being superseded by the extended-range 767-200ER. Some early 767-200s were subsequently upgraded to extended-range specification. In 1998, Boeing began offering 767-200 conversions to 767-200 SF, Special Freighter, specification for cargo use, and Israel Aerospace Industries has been licensed to perform cargo conversions since 2005. The conversion process entails the installation of a side cargo door, strengthened main deck floor, and added freight monitoring and safety equipment. The 767-200 SF is positioned as a replacement for Douglas DC-8 freighters.
767-200er.
The 767-200ER was the first extended-range model and entered service with LL in 1984. The type's increased range is due to an additional center fuel tank and a higher maximum takeoff weight, MTOW, of up to 395,000 pounds, 179,000 kilograms. The type was originally offered with the same engines as the 767-200, while more powerful Pratt & Whitney Palais 4000 and General Electric CF6 engines later became available. The 767-200ER was the first 767 to complete a non-stop transatlantic journey, and broke the flying distance record for a twinjet airliner on April 17, 1988 with an Air Mauritius flight from Halifax, Nova Scotia to Port Louis, Mauritius, covering a distance of 8,727 nautical miles, 16,162 kilometers. The 767-200ER has been acquired by international operators seeking smaller wide-body aircraft for long-haul routes such as New York to Beijing. Deliveries of the type totaled 121 with no unfilled orders. As of July 2013, 47 examples of passenger and freighter conversion versions were in airline service. The type's competitors included the Airbus A300-600 and the A310-300.
767-300.
The 767-300, the first stretched version of the aircraft, entered service with Japan Airlines in 1986. The type features a 21.1-foot, 6.43 m, fuselage extension over the 767-200, achieved by additional sections inserted before and after the wings, for an overall length of 180.25 feet, 54.9 meters. Reflecting the growth potential built into the original 767 design, the wings, engines, and most systems were largely unchanged on the 767-300. An optional mid-cabin exit door is positioned ahead of the wings on the left, while more powerful Pratt & Whitney Palais, 4000 and Rolls-Royce RB211 engines later became available. The 767-300's increased capacity has been used on high-density routes within Asia and Europe. Deliveries for the type totaled 104 aircraft with no unfilled orders remaining. As of July 2013, 59 of the variant were in airline service. The type's main competitor was the Airbus A300.
767-300er.
The 767-300ER, the extended-range version of the 767-300, entered service with American Airlines in 1988. The type's increased range is made possible by greater fuel tankage and a higher MTOW of 407,000 pounds, 185,000 kilograms. Design improvements allowed the available MTOW to increase to 412,000 pounds, 187,000 kilograms, by 1993. Power is provided by Pratt & Whitney Palais, 4000, General Electric CF6, or Rolls-Royce RB211 engines. Typical routes for the type include Los Angeles to Frankfurt. The combination of increased capacity and range offered by the 767-300ER has been particularly attractive to both new and existing 767 operators, allowing it to become the most successful version of the aircraft. Airlines have placed more orders for the type than all other variants combined. As of October 2013, 767-300ER deliveries stand at 582 with one unfilled order. Airlines had 533 examples in service as of July 2013. The type's main competitor is the Airbus A330-200.
767-300F.
The 767-300F, the production freighter version of the 767-300ER, entered service with UPS Airlines in 1995. The 767-300F can hold up to 24 standard 88 by 125 inch, 2,200 by 3,200 mm, pallets on its main deck and up to 30 LD2 unit load devices on the lower deck, with a total cargo volume of 15,469 cubic feet, 438 m3. The freighter has a main deck cargo door and crew exit, while the lower deck features two portside cargo doors and one starboard cargo door. A general market version with onboard freight handling systems, refrigeration capability, and crew facilities was delivered to Asiana Airlines on August 23, 1996. As of October 2013, 767-300F deliveries stand at 86 with 44 unfilled orders. Airlines operated 90 examples of the freighter variant and freighter conversions in July 2013. In June 2008, All Nippon Airways took delivery of the first 767-300 BCF, Boeing converted freighter, a modified passenger-to-freighter model. The conversion work was performed in Singapore by Saint Aerospace Services, the first supplier to offer a 767-300 BCF program, and involved the addition of a main deck cargo door, strengthened main deck floor, and additional freight monitoring and safety equipment. Since then, Boeing, Israel Aerospace Industries, and Wagner Aeronautical have also offered passenger-to-freighter conversion programs for 767-300 series aircraft.
767-400er.
The 767-400ER, the first Boeing wide-body jet resulting from two fuselage stretches, entered service with Continental Airlines in 2000. The type features a 21.1-foot, 6.43-meter, stretch over the 767-300, for a total length of 201.25 feet, 61.3 meters. The wingspan is also increased by 14.3 feet, 4.36 m, through the addition of raked wingtips. Other differences include an updated cockpit, redesigned landing gear, and 777-style signature interior. Power is provided by uprated Pratt & Whitney Palais, 4000 or General Electric CF6 engines. The FAA granted approval for the 767-400ER to operate 180-minute ETOPS flights before it entered service. Because its fuel capacity was not increased over preceding models, the 767-400ER has a range of 5,625 nautical miles, 10,418 kilometers, less than previous extended range 767s. Typical routings for the type include London to Tokyo. A longer-range version, the 767-400ERX, was offered for sale in 2000 but cancelled a year later, leaving the 767-400ER as the sole version of the largest 767. There is only the -400ER variant, and no -400 variant. The variant's only two airline customers, Continental Airlines, now merged with United Airlines, and Delta Airlines, received 37 aircraft, with no unfilled orders. All 37 of the 767-400ER were in service as of July 2013. One additional example was produced as a military testbed, and later sold as a VIP transport. The type's closest competitor is the Airbus A330-200.
Military and government.
Versions of the 767 serve in a number of military and government applications, with responsibilities ranging from airborne surveillance and refueling to cargo and VIP transport. Several military 767s have been derived from the 767-200ER, the longest-range version of the aircraft. Airborne Surveillance Testbed, the Airborne Optical Adjunct, AOA, was modified from the prototype 767-200 for a United States Army program, under a contract signed with the Strategic Air Command in July 1984. Intended to evaluate the feasibility of using airborne optical sensors to detect and track hostile intercontinental ballistic missiles, the modified aircraft first flew on August 21, 1987. Alterations included a large cupola, or hump which ran along the top of the aircraft from above the cockpit to just behind the trailing edge of the wings, and a pair of ventral fins below the rear fuselage. Inside the cupola was a suite of infrared seekers used for tracking theater ballistic missile launches. The aircraft was later renamed as the Airborne Surveillance Testbed, AST. Following the end of the AST program in 2002, the aircraft was retired for scrapping. E-767, the Airborne Early Warning and Control, AWACS, platform for the Japan Self-Defense Forces. It is essentially the Boeing E-3 Sentry mission package on a 767-200ER platform. E-767 modifications, completed on 767-200ERs flown from the Everett factory to Boeing Integrated Defense Systems in Wichita, Kansas, include structural strengthening to accommodate a dorsal surveillance radar system, engine nacelle alterations, as well as electrical and interior changes. Japan is the operator of 4 E-767s. The first E-767s were delivered in March 1998, KC-767 Advanced Tanker, the 767-200ER-based aerial tanker developed for the USAF KC-X tanker competition. It is an updated version of the KC-767, originally selected as the USAF's new tanker aircraft in 2003, designated KC-767A, and then dropped amid conflict of interest allegations. The KC-767 Advanced Tanker is derived from studies for a longer-range cargo version of the 767-200ER, and features a fly-by-wire refueling boom, a remote vision refueling system, and a 767-400ER-based flight deck with LCD screens and head-up displays. Boeing was awarded the KCX contract to build a 767-based tanker, to be designated KC-46A, in February 2011. KC-767 tanker transport, the 767-200ER-based aerial refueling platform operated by the Italian Air Force, Aeronautica Militare, and the Japan Self-Defense Forces. Modifications conducted by Boeing Integrated Defense Systems include the addition of a fly-by-wire refueling boom, strengthened flaps, and optional auxiliary fuel tanks, as well as structural reinforcement and modified avionics. All 4 KC-767JS ordered by Japan have been delivered. The Aeronautica Militare received the first of its 4 KC-767s in January 2011. Tanker conversions. The 767 MMTTO multi-mission tanker transport is a 767-200ER-based aircraft operated by the Colombian Air Force, Fuerza Aérea Colombiana, and modified by Israel Aerospace Industries. In 2013, the Brazilian Air Force ordered 2 767-300ER tanker conversions from IAI for its KCX-2 program.
Undeveloped variants. 767-400ERX.
Boeing offered the 767-400ERX, a longer-range version of the largest 767 model, for sale in 2000. Introduced along with the 747X, the type was to be powered by the 747X's engines, namely the Engine Alliance GP7000 and the Rolls-Royce Trent 600. An increased range of 6,492 nautical miles, 12,023 kilometers, was specified. Kenya Airways provisionally ordered 3 767-400ERXs to supplement its 767 fleet, but after Boeing cancelled the type's development in 2001, switched the order to the 777-200ER.
E-10MC-2A.
The Northrop Grumman E-10MC-2A was to be a 767-400ER-based replacement for the USAF 707-based E-3 Sentry AWACS, E-8 Joint Stars, and RC-135 SIGINT aircraft. The E-10MC-2A would have included an all-new AWACS system, with a powerful active electronically scan array, AESA, that was also capable of jamming enemy aircraft or missiles. One 767-400ER aircraft was produced as a test bed for systems integration, but the program was terminated in January 2009 and the prototype sold to Bahrain as a VIP transport.
Operators.
The customers that have ordered the most 767s are Delta Airlines, All Nippon Airways, and United Airlines. Delta Airlines is the largest customer, having received 117 aircraft. The Atlanta-based carrier is also the only customer to have ordered all passenger versions of the 767. Its 100th example, a 767-400ER, was delivered in October 2000. United Airlines was the only carrier operating all versions of the 767ER series, 762ER, 763ER, and 764ER, as of November 2012. The largest cargo customer is UPS Airlines, having received 59 aircraft as of October 2013. A total of 821 aircraft, all 767 variants, were in airline service in July 2013, with airline operators Delta Airlines, 94, American Airlines, 70, UPS Airlines, 56, United Airlines, 51, All Nippon Airways, 50, Japan Airlines, 48, LAN Airlines, 43, ABX Air, 34, Air Canada, 30, and others with fewer aircraft of the type.
Orders and deliveries.
Data through February 28, 2014.
Model summary.
Data through February 28, 2014.
Incidents and accidents.
As of February 2014, the Boeing 767 has been in 38 aviation occurrences, including 14 hull loss accidents. 6 fatal crashes, including 3 hijackings, have resulted in a total of 851 occupant fatalities. The airliner's first fatal crash, Lauder Air Flight 004, occurred near Bangkok on May 26, 1991, following the in-flight deployment of the left-engine thrust reverser on a 767-300ER. None of the 223 aboard survived. As a result of this accident, all 767 thrust reversers were deactivated until a redesign was implemented. Investigators determined that an electronically controlled valve, common to late-model Boeing aircraft, was to blame. A new locking device was installed on all affected jetliners, including 767s. On October 31, 1999, Egypt Air Flight 990, a 767-300ER, crashed off Nantucket Island, Massachusetts, in international waters, killing all 217 people on board. The U.S. National Transportation Safety Board, NTSB, determined the probable cause to be due to a deliberate action by the first officer. Egypt disputed this conclusion. On April 15, 2002, Air China Flight 129, a 767-200ER, crashed into a hill amid inclement weather while trying to land at Gimi International Airport in Busan, South Korea. The crash resulted in the death of 129 of the 166 people on board, and the cause was attributed to pilot error. An early 767 incident was survived by all on board. On July 23, 1983, Air Canada Flight 143, a 767-200, ran out of fuel in flight and had to glide with both engines out for almost 43 nautical miles, 80 kilometers, to an emergency landing at Gimli, Manitoba. The pilots used the aircraft's ram air turbine to power the hydraulic systems for aerodynamic control. There were no fatalities and only minor injuries. This aircraft was nicknamed Gimli Glider for the airport at which it landed. The aircraft, registered CGAUN, continued flying for Air Canada until its retirement in January 2008. The 767 has been involved in 6 hijackings, 3 resulting in loss of life, for a combined total of 282 occupant fatalities. On November 23, 1996, Ethiopian Airlines Flight 961, a 767-200ER, was hijacked and crash-landed in the Indian Ocean near the Comoros Islands after running out of fuel, killing 125 out of the 175 persons on board. Survivors have been rare among instances of land-based aircraft ditching on water. 2 767s were involved in the September 11 attacks on the World Trade Center in 2001, resulting in the collapse of its 2 main towers. American Airlines Flight 11, a 767-200ER, crashed into the North Tower, killing all 92 people on board, and United Airlines Flight 175, a 767-200, crashed into the South Tower, with the death of all 65 on board. In addition, more than 2,600 people perished in the towers or on the ground. A foiled 2001 shoe bomb plot involving an American Airlines 767-300ER resulted in passengers being required to remove their shoes for scanning at U.S. security checkpoints. On November 1, 2011, LOT Polish Airlines Flight 16, a 767-300ER, safely landed at Warsaw Frederick Chopin Airport in Warsaw, Poland after a mechanical failure of the landing gear forced an emergency landing with the landing gear up. There were no injuries, but the aircraft involved was damaged. It was possibly the first instance of a complete landing gear failure in the 767 service history. A preliminary investigation suggested a hydraulic leak and a deactivated circuit breaker as probable causes. In January 2014, the U.S. Federal Aviation Administration issued a directive that ordered inspections of the elevators on more than 400 767s beginning in March 2014. The focus is on fasteners and other parts that can fail and cause the elevators to jam. The issue was first identified in 2000 and has been the subject of several Boeing service bulletins. The inspections and repairs are required to be completed within 6 years.
Retirement and display.
As new 767s roll off the assembly line, older models have been retired and scrapped. One complete aircraft is known to have been retained for exhibition, specifically N102-DA, the first 767-200 to operate for Delta Airlines and the 12th example built. The exhibition aircraft, named the Spirit of Delta by the employees who helped purchase it in 1982, underwent restoration at the Delta Airlines Air Transport Heritage Museum in Atlanta, Georgia. The restoration was completed in 2010. Featuring the original delivered interior as well as historical displays, the aircraft is viewable by Delta employees and the general public by appointment. Due to hangar renovations, the aircraft is not accessible from June 2013 until scheduled reopening in July 2014. In 2010, 4 retired American Airlines 767-200s were dismantled for parts in Roswell, New Mexico, and their nose sections removed intact for collector or film use. Of these 4 aircraft, the cockpit of N301AA, the 8th 767 built and the first of its type to be delivered to American Airlines, was transported to Victorville, California, to be restored for museum display. As of 2013, the cockpit section of N301AA is housed at the interim museum location of the American Museum of Aviation, a non-profit organization in Las Vegas, Nevada, along with a display of American Airlines photographs. The organization is also attempting to restore the forward upper fuselage and cockpit section of N601UA, a former United Airlines aircraft and the second 767 built.
Specifications.
Sources: Boeing 767 General Specifications, Boeing 767 Variant Specifications and other sources.